So we start. We are here to speak about mass data purges. So, Proginov, my company. We are a publisher, integrator. We do our own support. We have 2 data centers, and we are managing more than 13,000 OpenHDB in production right now. I think it's the same number in test and pre-production. So I began my OpenH career 20 years ago as a developer. I've optimized Progress source code since 2005. I'm a DBA at Proginov since 2010. Oh, it's better like this. I'm dealing with more than 30,000 DB in production. Okay, so we are playing with a copy of the SPOR 2020 DB. I will suppress or something else more than 100 million records of other line, which means 5 gig of data. There is a screenshot of the DB analyze for the table which are dedicated in one area and the index on another one area. So we have a look on the percentage util, the level on the, use this. Yes, there is a level there, the percentage util there, which could be interesting sometimes. If you have a lot of activity on your DB, on your index, and you have a poor percentage util, you can have a performance issue. Or when the level is come from 3 to 4, you can decrease your performance about 20% sometimes. So if you are really active tables, it could be a huge impact. So I will show you these results every time. So, yes, what we'll do today, I will speak about unit transaction, the transaction size, how to avoid index on 3-lock read, good and bad color could defeat you, what is the advantage or disadvantage of 4GL code, and how to avoid some disadvantage. I will summarize some possibilities that we could have. So, first, unit transaction. Oh, I forget to say something. I'm using 2 boxes, a Linux box, where there is a Matrix on there, and this laptop. I'm using both sides because on the Linux box, there is my team which work on, and the performance vary a lot, so I cannot give you information on the times to do some test with. So, okay, first test was done on a Linux box. It's a unit transaction on for each order line, exclusive block, delete order line. And time is more than 3 hours. There is more than 60 gig of after-image note. And we can see that there is a lot of activity on the disk. There are a lot of write for each note. So benefit of packet size. This graph shows us the benefits of the packet size transaction on time. There is a time there. And on space for after imaging and before imaging file per packet transaction. For a unit transaction, we can see that there is more than 21 minutes to delete 10 million of records. And the after-image file notes is around 8 gig. When we do a packet transaction of 10 records, time decrease around 100 sec, and the inodes decrease also from 8 to 7 gig. And increasing the packet size from 110, 100,000, etc. to 1 million, 10 million, it decreases each time the elapsed time to do the deletion. And we could see that the before image did not increase until 1 million records. And for 10 million records transaction, it has the same size of after image note, around 7 gig. So 2 big transaction could be bad. So we've got this. So one precision. I do my test with the default parameters. So dash L was at 8,000. I could delete 10 million records with the dash L at 8. Yes. Because it's when you delete a record, the lock is all during your exclusive lock, and you delete the record, the lock disappeared. So you can delete several million records with the dash L set to 8,000. There is no issue on this. So you can have this. So when you undo delete record, you will recreate the record, put a lock on this table. So if you delete more records than dash L,
Crash.
no crash, not immediately crash. There is an increase of the lock table. And after, you will have this message, after share memory, use MXS to increase. And at this time, your DB crash. And you've got 2 transactions to undo. So first we try to undo and your mass deletion. So it could take a long time to do this. So to prevent this, we can use a file flag to stop the mass deletion. But do not test it for each record. It could be a performance issue. X, I test for X modulo, it could be 10,000, something like this, 20,000, it's up to you. Not for each record, because you will take more time to test the file flag than to delete the records. Or you can use a record to manage your mass data purge. In this code, we manage a gracefully stop at this point. And I'm managing also the size of the transaction with this. I'm changing the size, which is this size, variable trans size, which is used there. So, and I can add also a pause. Sometimes, if your system is overloaded, you can pause between transactions, which softens the effect of the mass data purge. But even if this gracefully stop is included in your source code, someone has to engage it.
It's manual.
Yes, it's manual. Someone has to engage it. So it will be better if the transaction could not be bigger than dash L. Yeah. So one workaround is to set audit feature on dev environment. For each table, create an audit delete level to its mini value. Yes. So each time you delete a record, you will create an odd audit data. And this record is locked until the transaction ends. So you cannot delete more records than in dash L. If you try to do this, you will have the message log table overflow increase dash L on server. So your dev team had to take care of a transaction size. During transaction, when a record is deleted, it's a progress notebook. What I will say you. During transaction, when a record is deleted, if there is a unique index, a delete placeholder is put in place of the rec ID for the deleted record until the transaction commits. Yeah. This is done so that another transaction running at the same time cannot add the same unique entry, which would thereby prevent the deleting transaction from rolling back. At the end of the transaction, it's converted to a negative number and put in place of the rec ID in the index as a placeholder. So I do this test, deleting several records from 0 to 10 million by packet size transaction of 10,000. The first loop of my iteration, I delete 10,000 records. It took 1.2 sec. I'm reading 10,001 records of order line. I'm reading 10,001 records of order line. Several loops after, when I try to delete the 2 million records, I will delete 10,000 records. It will take 1.8 sec. Read always 10,000 records, but index is 2 million. And each time it's bigger and bigger and bigger. From the last series, which is a 10 million delete, 3.8 sec to do this, 10,000 reads on order line, and 10 million reads on the index order line. And reading only, I'd say the placeholder, it took 2 seconds and 2.8 seconds. So it's more and more and more and more. So what can we do to avoid index on treelock read or placeholder read? First thing, easy thing, use another index. This is a simple way, but it's not a good way. If I want to delete all my order line which order name less than 3 million, for example, and I'm using item name, which is based on the field item, with a packet size of 10,000, I will reread all the order which are above order name above 3 million. So I will read and read and reread again the same set of data, and it will take a long time. So we have to find something else in this case. Another option is to run this in single user mode. In single user mode, there is no transaction active at the same time. So no need to engage the placeholder. So first test on this laptop. It's single user mode with unit transaction and after image disabled. It's a for each order line, exclusive lock, order name less than 30 million, delete order line. The result is it took more than 2 hours and 34 minutes. I will show you this set of results each time to highlight the placeholder effect. Yes, for this time, for each order line no lock took 1.9 sec to read them. The read on order line and the index order line are similar. So there is no placeholder, everything is correct. I'll show you an extract of the DB analysis just to show you these metrics. The percentage util and the level, they did not decrease, or quite small. It's due to the fact that there is a very few number of records in the DB. As there is, again, 100 million of records, this value will not be there like this one. It will be really higher value and better value. So another test, single user mode, 10,000 records per transaction, and after image, always disabled. So time decreased to 30 minutes. So for each order line took the same time. Read on index and table are quite similar, and there is no special requirement on percentage util and level. It's quite the same as the present. Okay. For this test, after imaging is enabled. I'm deleting 100 million records per transaction of 10,000. So it took more time, more than 46 minutes. The reads on order and index order line quite similar. Something special, it's high size. There is more than 55 gig of notes, but it's only on one file. There is no switch of IE due to single user mode. So if you are deleting more and more records than this, you must take care of your after image file size. There are some requirements to avoid the read of the placeholder in multi-user mode. So this is one. Multi-user mode, I will use a do while and a for each with multiple index. So to do this, I will use two variables, val order and val line number. I set the value of these two variables at the last record deleted in my transaction. I deleted 10,000 records, and per transaction, and for the 10,000 records, I set the value of this. And after I use a multiple index for each, this one and this one, I put this equals, greater or equals, because unique index are not really unique if there is unknown value. So to not avoid some records with unknown value, I always put greater or equals than to avoid this fact of unique value, unknown value, unique key. So it took 1 hour and 15 minutes. The read and for each are not the same. Yeah. Yes. I'm read something like 10,000 order line, but on the index, it's 100 million reads on the index because I'm reading the placeholder. So, and my after image note are something like 60 gig. Yes, so we can see the placeholder in the DB analysis too. At this point, the size of this index doesn't decrease. It's always near 1 gig because the placeholder are included in this size. We are not able to see the placeholder in a DB analysis. So it's the first way to avoid the read of the placeholder. There is a second way, which is use the dynamic queries. With dynamic queries, we always read the data in the same way. So we can do loops on our transaction at this point when I'm deleting 10,000 records there. I'm leaving this, but I do not reopen my query. So I'm starting at the point I stopped the transaction before. So do not need to reopen it. Do not read the placeholder. But time to do this deletion on 100 million records is 1 hour. And again, the read on the table and the index are totally, yes, I'm reading again the placeholder. So 1 million reads, 100 million reads of placeholder. So after image note, it's something like 55 gig. And I've got, again, the same issue on my index. So edx compact is your friend at this time. To suppress the placeholder, you must run edx compact on this index. So one of the advantages of multiprocess mode is the capability to run several mass data purge at the same time with several processes. Generally, I'm doing this with another table which manages my partition. I'm using small partition. For example, for 4 processes, I will use something like this, 30 subpartition. So I do not care how much data I will have in partition. If the partition is 2 times bigger than the other one, it's not an issue for me. The process will take time to delete it, but at the same time, the 3 other processes will delete 2 subpartitions each one. So globally, at the same time, I will report all my process. So, I'm using a code like this one to do this. I take my manage partition tables, changing its state there, doing my mass data purge there, changing the state to done, and take the next one available to delete the subpartition. Oh, the process are not so good in this laptop. Yes. Yes. No benefit by doing this. I think it's due to high latency on my disk and only one physical CPU. So, you speak about this, Tom? Yeah. Right.
I don't think it's really the disk.
Yeah, I think it's CPU. But with more powerful box and 4 process, generic divide time per 2. 4 process divide time by 2, per 2. Generate this. Okay, good and bad coder can defeat you. Before running a mass data purge, you have to check the transaction of source code which will be involved in the procedure. So there is my mass data purge. The procedure mass data purges. I start my transaction, delete my packet size, and end, and redo this. It seems to be okay. But you might check also the color. Oops. Yes. It's called there, and just after a good color, put an exclusive lock there. So all your mass data purge is on one transaction. Yes, sometimes you could use this. Abort if in transaction. If transaction, then return. No risk. Set of sweat. Okay. Good. Coder could defeat you also. If you're using audit features on test and not on production, this is a huge difference. Good coder could want to maximize the packet size transaction by executing code like this one. They want to stop the transaction when they use something like 80% on the log tables and stop transaction and restart it. But if you have no audit features, there is only one lock on the mass deletion. So they will never stop the transaction. And you have the same effect than before. Here are some advantages and disadvantages of 4GL process. They could be online, which is one big advantage. The other user could work at the same time. You could add control to align your process with your business rules. For example, you can delete the order line where the order date is under a specific date. You don't need to rebaseline your backup or your replication target. There are some disadvantages too. It could be slow, more than 1 hour for 5 gig. You have to deal with the placeholder or the index and relux, the free space. So remember, IDX compact could be your friend. Free space, 2 points in this one. Free space, first is after 4GL mass deletion, your DB have always the same size, except if your bay grows too much. And the other one could be the free space in the block. At the top, there is a schema of your table. There is a block in red. Well, one could say it's new records. We are relatively active. You read it more and more often than the other one. The blue one, which is all data that you want to purge, for example, and you read them, for example, 1 time per day. It's quite few. And there is the other one, which are between most active and not active. On the left side, this is a schema of the mass data purge, which follow your store order of your data, which is big deletion. So I will empty a set of blocks there. And when you will create new records, they will use this set of blocks. On the right side, this is a schema of data purges too small, which do not follow your store order of your data. So I will delete some records in each block. For example, there is 2 places remaining in each block. When I create the records, these records will go in this place. So new record will be dispatched on all the blocks of my DB. So with this little example, I think it will be easier to understand. So before the mass data purge, when I create a set of records, new records are in 3 blocks, 3 new blocks, which are at the end of the area, for example. I fire my mass data purge. The DB is order line is ordered by item, and dump and load them by item name. And I'm deleting with order name, which is not the same index. So when I create the same set of records, now records are spread in 9 blocks. So it will increase your disk read, 3 blocks, 9 blocks. So you could have performance issue if you are already active on this table. You can soften this side effect by updating your query and toss limit. If I increase it, I recreate the same set of records. Now I will use only 4 blocks because the blocks which are partially empty are considered as full. But it's not an optimal parameters. Query and toss limit are too high. I will lose some space in each block. It's not so good. So what you have to do is to set create and toss limit to the initial value, and you can use the proutil order item table reorg order line, which is a new feature. And after this, you will have the same things that before you mass data purge. Table reorg, new features. The primary goal is to work online on this feature without effect on the other users. It's always better to work online than offline. Like dump and load, table move, table reorg, physically reorder the records by the index that you chose. For table reorg, it's the unique index. So on this table, there is only one unique index. So data is ordered by item name now. So it could change something, have some side effect for you. If you previously order your data by item name because it's better for performance, now it will be ordered by order name and line name. There is also some strange behavior. One of them, it's the time to do this, near 7 hours. I opened a case last week on Wednesday on table reorg, and they gave me some information this morning, so they will improve the performance on this tool. This is in the pipeline. They will increase there is an increase of the size of the non-unique index. For me, it's normal to have this because when you delete and recreate the record with the table reorg, you're changing the variety of the records, so you're changing the index key, moving them elsewhere, so you will split the index, so it takes more space. For me, it's something logical. The afterimage file size is quite big. It's under investigation. There will be a fix soon, I think. And the most bad side effect is the size of the index area. Before it was 1.2 gig, and after table reorg is 1. Oops, yes. Oh, Progress has investigate, and there is already a fix in the pipeline. It's due to index manager. So, cool. We could use it quite soon. So, we can suppress the index on treelock on the fly. So, first, there is a trash zone there. The trash zone, it's, I can say, abnormal value for my index. For example, for order line, the order name negative value is a trash zone for me. Data will not be there normally. So it's my trash zone there, and there it's a picture of 2 blocks of index. In red, there is placeholder, index entry, which for deleted records. In blue, it's real records. So it's the first step of my iteration. The next step is to suppress all the records and leave 1 record per index block, at least 1 record per index block. So I've got a lot of placeholder, 1 active record in each block. The next step is to update those records. So I will set a negative value to the order name, for example, and what is special, suppress does not delete placeholder, but an update is updating them. So by doing an update, I suppress the placeholder, I suppress all the placeholder of the block if the transaction ended before. So by doing this, I will suppress all the placeholder in these blocks. And
you're saying you're updating 1 key per block. That's your goal, right?
yes,
And that
at least 1 key per block.
to clean the whole block.
Yes. After the first transaction, which delete all the records. So, and after I'm deleting the records that I put in the trash zone.
But how do you know what block is your record in?
So I do some tests before. I test it and try to set it to a value. Try 10,000 record to have a picture of code. I must try to several tests. I'm using this code to answer you. In fact, except for very big index key, this value works relatively fine. So what I do in one iteration is first thing is suppress the record in the trash zone. It's 2 variables which are negatives. Those one. Second step is to update the records from the deleted blocks, go to the trash zone at this point with this. With this. This, I put a negative value on order name, so the index goes to the trash zone, and I suppress the placeholder in the block. And I finish by deleting all the records except 1 to 45 to the next loop. By doing this, it took 1 hour 20 minutes, and the goal is this one. I'm in multi-user mode, and the read on order line is something like 3.5 sec. And the read and order line in the index order line are not similar, but it's more normal. It's not 100 million read on the index. And there is a big part of the placeholder which are negative value. In fact, in my trash zone, there. So you can have a look also at the size of the index order line. It decreased from 1 gig to this, which is relatively small. But again, the level does not decrease. So, how to avoid some disadvantage of 4GL. So you can use partition delete. In this case, I've got 4 partitions, my composite initial that I want to delete, and other partition with relatively few records for the test. And you can see my global index and my partition index there. I will use so proutil, say partition manage truncate table order line composite initial. It could be your partition also. It took 18 minutes to do this. After image file size, it's 21 gig. Everything seems correct on this side. So depending on the size of the data you want to delete or preserve, first it's quite similar, or 100 million, 100 million to delete or preserve, or I will say 1 million to delete, 1 million to delete, 100 million to preserve, or 100 million to delete and 1 million to preserve. Massive data purge could be delete all quickly and recreate some of them. Yeah. It could be the same effect. But if you have a small part to recreate, it could be faster. So first way is to use a trigger. You can create a new table like underline, can choose your area, put the same area as underline or another one, it's up to you. Define a write and delete trigger on underline to propagate the create, update, and delete on underline, because other users could work at the same time on this, on the new table. Do not propagate a record you do not want to preserve, and filter your data to copy the order line you want to preserve in the new table. Time to do this is 1 hour 25, more or less. And after this, you can drop your table with a schedule, which is instant if you're using tip 2 area, and rename your table with a load df. But you must take care of SQL, right, permission on the new table. You must set them as your old table. As a whole, the space because you have at one time you have the old line and the new table also. Yeah, it could be.
We are using this approach in some cases, but we copy the other line because we want to preserve the them tables.
Yeah, but if you crash, you lose your table.
Yes, the creation of that copy is for
One other approach, it's binary dump load. You must shut down your DB, disable your after image, do a dump specified. You could truncate your area if there are only one tables and index in your area, it's dedicated area. You could truncate them, rebuild your index to be able to do table move to another index. At this time, you could remove your area, so you will win the space. And after, recreate your areas, table move again, load, index build. To do this, it's 10 minutes on 5 gig data. But after, you need to enable your after image and rebaseline your backup. So it could take a long time to do this, depending on your DB. So there is another way to do it. Always use them specified. You can table move your data to truncate it and use a binary load with the option build index. It took more time, 40 minutes. That's 41 minutes. I file size is 40 gig, but it's after image file size. So, I do not need to disable my after image at this point. Purges and error-FTL -C roll forward works across this process. So you do not need to rebaseline your backup. I do not test replication, but Paul say it should work. One constraint is you must use only one binary dump file to load, because the first step of the load index build is to deactivate all the index. So you can use this trick if you have to several binary dump file. You do several dump specify. You load them in another DB, which tip 2 area, and you can dump it using index 0. So you do not need to rebuild the index. You win some time like this. And after, it's the same thing. Table move and load with build index.
12.4, right? The dump specified is available in 12.4?
No. It's a 12.4 due to table move or the line truncate, which is an option of 12.4. But dump specify, I think it's with perhaps 10, 10 something. So, to summarize, we've got this option. We have got several other options. So it's single user mode, which different packet transaction. It's up to you to choose your size. So for the first, after imaging was disabled, so quite fast. You must take care of your index, percentage util, and level. Probably if it's a very active table, really have a look on it. If an index compact decreases your level, you will win times. Your user will win times. But the disadvantage is DB is offline, so you cannot do anything else except this. There is a multi-user process which will not suppress the index of TreeLock as a placeholder like more times, and you need to compact your unique index. There is the trick to suppress the index of TreeLock on the fly, which take more time, and you must have a look at the other index. And there is the triggered option and the dump and load binary dump and load option. The disadvantage of the last one, you cannot have create, read, update, delete on this table at this time. If you do create, update, delete on this table during your process, you could lose your data. It's bad. And read, depending on the time when you are doing it, it's just after the table truncate, you have no data. So you could mix some process. There is 3 ways to empty the tables: SQL dump, table reorg, truncate area. You could mix dump and load and 4GL mass data purge, decrease the number of records to delete with a dump load, and after do a 4GL process to delete the other data. You could use also offline and online process if you want. If your online window is too short, begin with it and finish with an online process. It's up to you. Have any question? Yeah?
Sorry, I missed the beginning.
Yeah.
But I don't see anything about the BI file.
No, in fact,
Yeah. So I will go.
No.
No problem.
Répète la question.
Répète la question.
Yeah. Alors, the question was, is there some effect
on the before image file.
Did you did something with that tuning situation? Because all the times are dependent on the throughput of the BI file.
It's there.
Okay,
There.
this one, sorry.
Yes, but yeah. There is your packet size,
Yeah.
1 unit transaction, 10, 100, 1 million, 10 million records per transaction to delete. And you can see the files of the before image file, which increase at this step. In this case, just in this case.
Yeah.
So before, it's not increased the initial value.
And if there are other users creating long-running transactions,
There could be a duty impact. As there is a long running transaction and you are doing mass data purge this time, there is a huge impact on the before image file, except if you're on the last release of page 12.
With the watchdog and delete the block in the before image file. So, but good question. It's the same with edx compact. If you are running in edx compact and there is a long active transaction, you have the same side effect.
but you could check that before you run the delete and then sleep if it's run.
Yes, you have to. Other question?
Did you try with different box sizes and different clusters? I tried this with
Did I try with several boxes? This was the question. I'm using two boxes, the Linux box and this laptop to do my test. First, I was playing with the Linux box and my results were almost crazy because the other DBA and the IT team are doing some tests on this VM, so sometimes are bigger than 3 for the same option, the same set. A copy of the DB, I do 3 times the test, and the time is very a lot. So I prefer working on this laptop, which is more secure.
From the chat, would you say upgrading to 12.3 to use the table reorg is worth it?
No, table reorg is a good option. What you want is to reorg your table online. This does the job, but you must take care of your index. If it's a 1 terabyte table and you have 100 gig of index area, take care, we don't know how much space. Test it before.
So after the fix is going.
After the fix, it will be better.
Sure. Sure. And run from tech support at Rotterdam, Sydney could be what would be faster than this.
Cool.
No question?
Well, you are now looking at deleting tables that are used for creation of updates and stuff. Have you ever done something particular with the CDC records, which are only created, so they are continuing to grow, and you want to delete what has already been processed? So you delete the first part and you leave the last part maybe.
It depends on what you want to CDC. I'm using CDC. I developed my own proutil.
Yeah,
Yes.
yeah.
Yeah. So for CDC, it's I can delete it when I treat the CDC record. When I transfer to the new DB my record. So at this time, I can delete it. So it's not mass data purge. It's on the fly. I show it. I can lock it.
I transfer and delete.
Okay.
It's not really like this because I'm not using the same version of Progress. It's between 11 and 10. So I cannot delete the CDC directly with.
And if you want to keep a little bit of history, like a week worth of transactions.
So there is two ways in CDC. So
there is some level, different level, I think. There is you have to allow the deletion of the record. I think it's you have a command line to allow you to delete it. Yes, or you have the enough wall to delete directly your record. So, but I don't know what are the unique index on this table. I think there is one record, which is one unique index, I think. So you must take care about it, but you are not deleting on this one. I think it's a GUID, which is, so you are not using this index to delete. So.
I have just a tip from Ruan here.
Yeah.
On the chat, she said, if you play with Sports 2020, remove the encryption area unless you're testing TCP.
Yes. It was again a case that we opened with them. In Sport 2020, with the default area you've got area for encryption, audit, and probably something else too. But the simple fact that you have your encryption area start the mechanism of encryption, even if you did not activate this option. So in case of you are loading a lot of data of other line, you can have a latch on encryption. Yes, it's just due to this fact, because you can activate this feature online. So the working on encryption, if you have the encryption area, they are working, preparing the workflow, and they say us, why do you have an area for encryption if you do not use this feature? Yes, Paul?
MTLEC latches, that's what Ruan says.
Yeah. Yes?
Did you ever partition your data and then delete it?
Yes.
Yeah.
If you did the partitioning of your data.
Yes. You partition my data. And to partition data,
so something partition. Well, with partition, you must align your partition and your business rules. You must take care. Yeah, and this one. Yes, with partition, I make a try with this, and I don't take care. It's composite initial because I don't want to work too much on this side. Yes, your partition must be aligned. You must take care about this. If you have business rules on order that, for example, and you use composite initial, a partition delete, take care. Check it before. No more question?